We'll try to make them a little bit shorter. So this, we're going to look at the page, basically we're going to focus on one page, page 374, where they have some examples, and then they have some exercises that we can try. But don't worry, your heart rate won't get too high. Anyway, so when we name these, like it said, the first thing we want to do is find the longest carbon chain. So this first example right here, and it has the name and everything, but let's go through how they found this. So this could be carbon 1, 2, notice if I count it that way, that would be the 3 carbon. That would be my longest chain. So my longest chain should be 1, 2, 3, 4. That's my longest chain. And notice if I count it the other way, 2, 1, 2, 3, 4 could be the longest carbon chain that way. Interesting. So why is it the way it is? Why do they have 1, 2 here? Well, they have 1, 2 there because we want our substituent group on our smallest numbered carbon. So that's why we can't start 1 over here. We have to get the substituent on the smallest numbered carbon. And notice we could have counted this a different way. This could be carbon 1, and this 2, and this 3, and this 4. But if we would have numbered it that way, or with this as 1, like it says, it would have the same name. So what this is called, this is what one of my one instructor that I worked with at a conference called this. It's called Name 'em and Shame 'em. So if you name them, no matter which way you turn them or look at them, if you name them correctly, they're always going to have the same name. Any way you turn them and spin them and look at them. So we want to name them and shame them. I don't really know what that means, but that's what I was taught. So that's what I'll teach you. So we want to name them. So again, this is 1, 2, 3, 4. That's my longest chain. This has the substituent group on my smallest numbered carbon possible on that second carbon. And so the long chain is a butane. This is butane. This beginning part is what's attached to it, the methyl group. And it's on that second carbon. So it is 2-methyl-butane. That is where they're getting this. Again, just, I don't know, to make it more confusing, if I would have named this the other way, if this would be 1, 2, 3, 4, that is perfectly fine. But again, that's still a butane. And then notice, where is this methyl group? Well, that methyl group is still on the second carbon. So it is still 2-methylbutane. So if we name it correctly, any way we orientate it and look like, it should have the same name, right? Okay, the next one here. Now this one's a little bit easier because it's clear what the longest carbon chain is. This is the longest carbon chain. Now notice we have to start counting from the right side because our substituent group is on the second carbon here. So 1, 2, 3, 4, 5 carbons. So it's a pentane. That's what I always start with, is the longest carbon chain. Next, the substituent group is a methyl group, and it's on the second carbon. Again, notice we could have actually named this a little bit differently. If I clear this stuff off here, I could have gone from 1, 2, 3, 4, 5. But again, it would still have, it's not hiding. It can't play pretend. It's still a pentane because it's still 5 carbons. And the methyl group is still attached. So we can't get confused. It's a 3-dimensional structure written on 2 dimensions. It gives it a shape and a form that it doesn't have in real life. So don't worry about one thing being up or down or anything like that. That means nothing. It means nothing. It's just trying to represent it in 2 dimensions, a 3-dimensional structure. So 2-dimensional representations of 3-dimensional things, ooh, it doesn't really work. Anyway, 1 at the bottom. Ooh, see, these are like, this is a nice structure. We have our carbon chain, and notice it's only carbon, so that's easy. That's propane. And then what do we have attached? We have chlorines on the first and second carbon. No, not on the second and third. We'd want this to be carbon 1, because we need our substituents on our lowest numbered carbons. That's how we keep track of them. So 1, 2, 3. That's our propane, again, singly bonded. And then now, it's 1, 2, dichloral. So di is 2. The 1 and 2 are telling us the positions of the chlorine. So there's chlorine on 1, 2, dichloral. Notice we could have 1, 1, dichloral. What would that look like? Well, 1, 1, dichloral propane would have those chlorines both on the first carbon, which is perfectly fine. That's acceptable. Notice it would have the same number of carbons, the same number of hydrogens, but our chlorines would both be right here on that first carbon. So we could have 1, 1 or 1, 3, right? Or perhaps 2,2-dichloral. Okay, so this is telling us just the position of the chlorines. It's pretty clear, actually. I like this. Now, on this one, we're trying to find the longest carbon chain again. Notice this has a chlorine attached. That's a substituent group. So regardless of which way I number this, this has to be carbon 1. Okay, that's my substituent group on the lowest numbered carbon. Then this has to be carbon 2. I notice either of these could be carbon 3, and it will be the same. Oops, sorry, I skipped away from it. It'll be the same either way we name it. So I'm going to label that carbon 3, just so it's clear. So this is my carbon chain. That's propane. That's the longest carbon chain. Now we have a chlorine on the first position, so 1 chloral, and 2 on the second methyl. Now you wonder why it's 1 chloral, 2 methyl. What about 2 methyl, 1 chloral? Do we put them in numerical order? How do we put these things in order? Well, typically these substituent groups, if there's more than one, they go in alphabetical order, which I don't know if you like that or not, but typically they don't go in numerical order. They don't have to be, the first thing doesn't have to be first, the second thing doesn't have to be second in the name. Normally we put them in alphabetical order. So notice that's important when we get to this structure where we have a propane again, because that's our longest carbon chain. Now 2 bromo and 2 chloral. So they're both on the second carbon, the middle carbon. Bromo comes first because it's a B, and B comes first in the alphabet. So if you need to review your alphabet, it's a good time to do that. Okay, so some easy exercises, some a little bit more difficult. So what statement is true about homologous series? And this is, notice, an International Baccalaureate question from a past paper. They all have the same empirical formula? No, because they have different sizes, right? Homologous series means they all have one additional one of these. So they differ by a CH2 group. Yeah, that is right. And let's just make sure the other ones are wrong. They possess different functional groups. Nope, then they would not be a homologous group. They all have to have the same functional groups. They differ in the degree of saturation. Ooh, saturation. That's a word we haven't gotten to. It's right in the beginning of your book. They have a list of words you need to know. That'd be decent to look at. I didn't look at it yet because it's a little early, I feel like. But unsaturation means the number of carbon bonds. An unsaturated carbon bond would be a double bond or a triple bond. That would be unsaturated. Okay? So do they differ in their degree of unsaturation? That would be different functional groups. So that's not possible. But these are unsaturated carbon bonds. Single bonds would be called saturated. Kind of a side point there. 2. Which type of compound must contain a minimum of 3 carbon atoms? Ooh, this is interesting. An aldehyde. Well, what's an aldehyde? An aldehyde is a carbon with a double bonded oxygen on the end. That's an Al group. So does that need 3 carbon atoms? No. No, it doesn't. We could have an aldehyde with less than 3. We could have 2 carbons. Carboxylic acid. Well, carboxylic acid is a double bonded oxygen and an OH group. And actually you can have methanoic acid. You can just have a single carbon to give you that. In ester, that's a good question. Maybe we should skip back to an ester. That's kind of our higher level. But again, standard level has to be able to recognize it. An ester has to have a double bond, oxygen, and then a carbon at the end. So this is getting close, but this actually could have a hydrogen here, and this could just be a methyl group. So that is possible to just have 2 carbons in the ethyl. So this is a single carbon, this is a single. Ketone is the one we're looking for. That has to have 3 because that has to have a carbon doubly bonded in the middle of a structure with carbons on either side. So a minimum to have a ketone is you have to have 3 carbons. So to do any of this, obviously you have to know your functional groups. The only way you know functional groups, there's no way to understand them. It is a nice term we like to call memorization, and that's really the only way to do it. Okay, name the following molecules. Finally, this is what I've been waiting for. Some fun. So we get to name these formulas. So I like to draw them out to be able to name them. It makes it easier for me. So CH3 is a CH3 group. And again, if you draw the full structural formula anytime in IB, do make sure you indicate all the hydrogens. It doesn't like them if we leave them off. IB is an it. So CH3, CH2, CH2, CH3, CH2, CH2, then a COOH. What is that COOH group? What does that mean? That means we have this. There we go. So, first step, count my carbon chain. Again, I count from this side because that's where my functional group is. So 1, 2, 3, 4. So it is a bute and, again, the and is because these are all single bonds, single bonds, single bonds. So bute, 4, all single bonded, and then my ending is what is this group on the end when we have a double bonded oxygen. Single bonded alcohol group, oic acid. This is a bute and oic acid. So really 3 parts to the name. The carbon chain, the type of bonding it has, and the functional group on the end. Beautiful. Next one. CH. So I'm going to draw down CH. Cl2. Well, if it's CHCl2, it's indicating those chlorines are bonded to that carbon. And now CH2 group, which would be this. And then the next part of my condensed formula is a CH3 group. Okay. So again, first thing, find the length of the carbon chain, which is pretty easy to tell here, but let's make sure we number it in the right direction, which would be 1, 2, 3. 1, 2, 3, because that gives my chlorines on my smallest numbered carbon. We want them closest to 1. So 2 chlorines. Well, first carbon chain is 3, so it's propane, ane, because they're all singly bonded, and then just an E, because these are substituents, so they go before. So this is a propane, and what's bonded to it? Well, it is 1, 1, di, because there's 2 of them, chloro. 1, 1, dichloropropane. Nice. I like it. It's going pretty good. Next one. CH3 is there. A CH2 group. And I feel like the only way you can name these is draw them out. I don't know. Honestly, I'm not that good to be able to look at the condensed formula always and figure out the name. If it's really easy, maybe. But, nope. Not. Most of these are a little bit too complex for me to just see the condensed formula and know how to name them. Okay, so we have 4 carbons. I'm going to number it this way. 1, 2, 3, 4. That gives me this group on the lowest numbered carbon. So it is 4. So it is a bute and because it's singly bonded. So those are my 2 parts of my name. Bute and then what is this group? That is our ketone group, right? So butane, how do we name ketones? One, butanone. And now we do have to put in the number, because notice that butanone, this double bonded oxygen could be here or here. Wait, would that change the name? It really wouldn't. It couldn't be on the 3. So we probably could get away with just calling this butanone. Maybe butan-2-one would be a little bit more clear, but we actually do not need that 2. It's butanone, because notice if we put that double bonded oxygen here, it would still be butan-2-one, because then we'd number it in the other direction. So it's bute and one. We don't need the 2. All right, next one. CH3. And all of these thus far have been standard level questions, by the way. C. And I'm just saying that because I can tell that this one, no, is not going to be standard level, because now we have that nitrogen bonded to the double bonded oxygen and a CH3 group. Ooh, this one's nice and complex and a good higher level question. Now, what is our longest carbon chain? 1, 2. So it's 2 carbons long. So that makes it F is our carbon chain. And we can say ethane because they're singly bonded. There's no double bond there. So 2 carbons singly bonded. Now, our functional group here, this carbon double bonded to an oxygen with a nitrogen, is called an amide. So it's ethane amide, right? So that takes care of this, but it doesn't take care of this attached. This CH3 group is called a methyl group. And if there's a methyl group bonded to my amide, it has to go in the front. So it is N-methyl ethanamide. Okay? And again, N, because the methyl group is bonded to the N, to the nitrogen, we don't put a number in front because that would indicate it's bonded to one of the numbered carbons. a couple more, and then we'll be done here. So it's CH3, so 3 carbons, and they're not giving it in quite the condensed formula. So 3, and then a carbon and a nitrogen like this. And 1, 2, 3, 4, 5, 6, 7 hydrogens. So my length of my carbon chain is 1, 2, 3, 4. Notice I'm starting counting here because that's where my functional group is. It says bute and bute because it's 4 and because they're singly bonded. And now my ending bute and this, if we have a triple bonded nitrogen on the end, is a nitrile group. And that actually is a standard level group. So butane nitrile. Okay. Last one here. We have this long structure. So CH3 followed by CH2. And again, I'm just reading down the line here. Another CH2, another CH2, 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 another one. So 1, 2, 3, 4 carbons. And then this group is telling me there's a double bonded oxygen, single bonded oxygen, and then this group. I'll write that a little bit differently on the end. Okay? Again, it takes a little practice to convert those condensed formulas into the structural formulas. But my longest carbon chain here, it would start here. It's 1, 2, 3, 4, 5. So we have a pentane. We have a pentane because, again, they're all singly bonded. There's 5 of them. This is my functional group, and this is the bit that's bonded to my functional group. Now this, by the way, is a higher level structure. Thankfully, I think for you. The standard level people are thankful. This is an ester, and its ending is an O8. So this is pentanoate. That takes care of this. But we do have to say the part that is attached to the pentanoate, and something has to be attached to this to make it a pentanoate. Otherwise, if it's just a hydrogen, then it's a pentanoic acid, right? But there's a group attached. A group is two carbons, so it is ethyl. It is ethyl pentanoate. We don't have to say the number because it is a pentanoate. We know that carbon is attached to the oxygen. So there we go. Those are our exercises on naming. So now what we're doing is we are going in the other direction. We want to draw the formulas from the names. And it says the condensed formula is acceptable, but it's kind of hard to, I'm going to do both because it's kind of hard to write the condensed formulas if you don't know kind of all the structures at first. So hexanoic acid. So hex means 6, and means singly bonded, and oic means it's a carboxylic acid group. So 1, 2, 3, 4, 5, 6 carbons, all singly bonded, and oic acid means there's a carboxylic acid group on the end, and I'll make that. And then one thing is we can't leave our carbon chains like this, not at IB anyway. Sometimes when you get to be an actual organic chemist, they will allow you just to make the skeleton structures to make, and I'll show you what I mean here in a second after I get done drawing all these hydrogens. So you need to make sure all the hydrogens are there at the IB level. When you go on to be an actual organic chemist, they'll allow you to draw structures like this. So where each of these points counts as a carbon. So 1, 2, 3, 4, 5, 6. And then show that double bonded oxygen and that alcohol group. Now I shouldn't even show you that because you're not allowed to do that. But you might see some examples when we look at practice problems where you see that. So you should kind of be aware of just what it is. So this is my hexanoic acid. My condensed structural formula would probably be CH3. This is my CH3 group, followed by 1, 2, 3, 4 CH2 groups. So I'd write that, open parentheses, CH2, 4. So those are 4 in a chain following, and then end it with my carboxylic acid, COOH, is how we condense a carboxylic acid group. So notice it still has the right number of carbons. 1 plus 4 is 5, and that one is 6, carboxylic acid group. Here's our condensed formula. Here is our full structural formula. All right. continuing. Butanal. Butanal. So but and al. But means 4 carbons. And means they're singly bonded, which I showed. And al is an aldehyde. Double bond action on the terminal carbon. Make all my hydrogens here. So I drew my hydrogens a little bit different. Doesn't really matter. A couple different ways you can draw them. So that's but. That's 4 carbons. And single bonded. Al means aldehyde. If I drew my condensed formula, it'd be CH3, CH2, CH2. I'm not going to put it in parentheses because there's only 2 of them. But then I write this group. And this is important. This group is written as CHO. So that is an aldehyde. It's different than if you write it COH, would indicate it's an alcohol. We don't want to do that. We want to make sure we write it as we would in aldehyde. Okay. Clearing my writing and going on to pent. 1-ene. Pent is 5, right? So 1, 2, 3, 4, 5. Ene is telling me there's a double bond. The 1 is on the first carbon. And now I can fill in my hydrogens. And be careful with filling in your hydrogens. Remember, every carbon can make 4 bonds. So the terminus carbon has 3 hydrogens. The carbon in the middle has 2. This one would have 2 hydrogens. This carbon now, be careful, it already has 3 bonds. A single and the double counts as 2, so it could only have 1 hydrogen. And my terminus carbon over here could only have 2 hydrogens. So we do want to be careful when we write that out. I'll write it out as CH3, CH2, CH2, CH, because it only has 1 hydrogen here. So that's my CH, CH2. That is telling people there's something going on and there's a double bond there, because it doesn't have, it's not fully saturated. So this, by the way, would be an unsaturated bond. Unsaturated. If we have triple bonds, they're called unsaturated bonds. Okay, 1 bromo, 2 methyl butane. Butane is my chain, so 1, 2, 3, 4. 1 bromo. Again, we have to decide which our 1 carbon is. Doesn't really matter. I'll start over here. This will be my 1 bromo. And then 2 methyl. So on the second carbon, we have a methyl group. Methyl group is a CH3 group. And that's it. 1 bromo, 2 methyl. Now I just have to throw in my hydrogens. So again, every carbon needs to have 4 bonds. So 3 hydrogens there. 2 on this carbon. 1 on this carbon because it's also bonded to the methyl group. And then 2 out here. Now, probably how I'd write this is I'll write this in the reverse order. I'll put that CH3 group and then CH2. And then how we write this as a condensed formula is we write CH, right? CH3, CH, CH3. That's showing that that's all bonded together. And then the last bit would be CH2PR. And sometimes what you'll see is that this will be put in parentheses, showing it's a substituent, so it's bonded to that carbon in there. Okay. Does that always have to be? Let me think. I think it would probably be best if we do put that in parentheses to make it clear. Okay, ethyl methanoate. So methanoate means a single carbon, and in O8 is a double bonded oxygen, single bonded oxygen. This is our O8 group, and it has to have a substituent attached. So this is my methanoate, and the group that is attached there is the ethyl, which is a 2-carbon chain. That is what an ethyl group is. So this is my ethyl methanoate. Right? Now, how do we write this? We would write this by saying HCOO, and then this group, CH2CH3 is how we'd write that. So COO inside of a structure indicates it's our OA group. Okay. So again, by the way, these have all of these are standard level. It's not until after that we're looking at higher level structure. So hexanoid. Hexan means 6, 2, 3, 4, 5, 6. Amide means there's an amide group. Now it's not an amine. An amine would just be this. An amide means it's double bonded oxygen. and a nitrogen group on that terminus carbon. And now we would fill in our hydrogens if we were writing the full structural formula. And you know what? Even if they ask for the condensed, this is how I figure out what the condensed formula is I have to write it out. Maybe my brain, I can't convert it directly into a condensed formula. I have to write the whole thing out. So CH3, followed by, I'll put all these in a chain, 1, 2, 3, 4 carbons, so open parentheses, CH2, 4, and then followed by this group. How do we write this group? We write this final group, CONH2. And how do we know how this is written? We've memorized it. That is it. Okay, last one is G. So again, both of these are higher level. At standard level, again, you need to recognize what this group is, but you wouldn't have to name the whole compound. So kind of goofy. Anyway, that's just the way it is. Hexanamine, dimethylhexanamine. Okay, so again, don't worry about the crazy name. Just look for look for what that longest chain is. It's that hex. So we always start with what the longest chain is, even if there's a lot of other craziness going on. So hexane, all single bonded. I got that taken care of. In a amine group, amine is our nitrogen NH2 group, would be an amine, but notice there's something attached to that amine group, NN-dimethyl. NN is a trigger right away that you know something is being attached to the nitrogen. Well, one, that there's nitrogen in the compound, and two, that something's attached to it and says dimethyl. So there's two methyls attached to my nitrogen. A CH3 group here, and a CH3 group here. That is NN-dimethyl, two methyls. Now just fill in my hydrogens, and away we go. And then I'll try to write the structural, or the condensed formula. I think in the back of your book it only has the condensed, it doesn't write all of these out. But you know what? That's kind of a disservice, because there's IB questions that do ask you to write out the whole thing. So anyway, now condensing this down, it'd be CH3, if I start here. And then notice this big chain, there's 1, 2, 3, 4, 5 CH2 groups, CH2, 5. And then this last bit at the end, typically how I would see this written is N, open parentheses, CH3, 2, indicating those two are both bonded to the N. There we go. So a lot of naming exercises. This will take a while. If it all is not currently crystal clear, what I would tell you to do, look at those functional groups. That's the biggest thing you can do. That is going to help you. 371 is you have to know the functional groups before we can worry too much about naming. So this is exercises on page 374 and 375. 1 through